1 ratio concepts. If you haven't done so, please take the time to glue in 1, number 2, and number 3 on page 16. So if you would please, go ahead and start right here. There are 3 boys for every 6 girls. I'm going to highlight this. This is important. It's important for our information for ratios. So there are 3 boys for every 6 girls in a movie. And if there are 24 girls, how many boys are at the movie? Alright, we're going to start by filling in some of these blanks here with information that we have in this. So for every 3 boys, there are 6 girls. We want to know how many boys are at the movie. So this tells us if there are 24 girls at the movie, how many boys would there be? So we've got a ratio we built. And we write an algebraic equation from this as a proportion. 3 over the mystery number x of how many boys is equal to 6 girls to 24 girls. Alright, so 3 to 6. So x for the boys to 24 girls. Okay? We can do what we call multiplying the diagonals and dividing the other side. That means here's your diagonal. 6 times x is 6x. And 3 times 24 is 72. So we multiply the diagonals. Now we divide the other side. So I'm going to put a fraction bar under each side of this proportional equation, which means divide. And 6 divided 6 to get x by itself, because that means 1 x is left, is equal to 72 divided 6, which is 12. So that means our answer is 12 boys to every 24 girls, and so in your statement you would write 12. There are 12 boys at the movie. Let's go down to the next one, number 2. A store sells a package of 25 trading cards for $5.25. What is the cost of 1 trading card? Alright, so we know that 25 trading cards cost $5.25, but we don't know how much 1 would cost then. So yes, you can probably figure this out without an algebraic equation, but I'd like you to build the proportion in order to see the relationship. So that means 525 over that mystery number of x is equal to 25 over 1. Now we follow that rule. Multiply the diagonals and divide the other side. So multiply your diagonals. 25 times x is 25x. And that is equal to 5.25 times 1 is still 5.25. Now we've multiplied our diagonals. We divide. So I'm going to write a fraction bar under each side of this equation, and that fraction bar means divide. 25 divided 25 leaves me with x, and 525 divided 25 leaves me with 0.21 or 21 cents. So I'll go on over here, and you can write the 0 or not in front of it. For spacing sakes, I won't. But I've got to put a dollar sign here for the real world statement. The unit price is 21 cents per card. Okay? Let's go on to the next one. This has got more steps to it. Number 3. A car travels 374 meters in 17 seconds. Okay? But a bus travels 414 meters in 23 seconds. So which vehicle is traveling faster and how much faster? So what we're doing is like a unit rate problem. I'm going to fill in the boxes with information I know. 374 in 17 seconds. So this is what I'm trying to find here. Over here, 414 corresponds to 23 seconds. Now let's build our proportional equations. I'm going to write this one out to the left, but you can write it on the left or right. So we have 374 over x equals 17 over 1. Multiply my diagonals, divide the other side. So 17 times x is 17x. And that's equal to 374 times 1, which is 374. Almost done. Now we divide both sides by 17. So fraction bar and fraction bar cancels out this side. X equals 374. Divide 17. Think about it. I'm going to ask you to calculate it out as I do the same. Did you get 22? Because that's what I got. So I'll write X equals 22 here. So this means 22 meters per 1 second. Now let's look at this part of the problem. We have to solve this one first. I'm going to take a little space over here to the right. So our proportion would be 414 over X is equal to 23 over 1. So you multiply your diagonals. X times 23, that's 23x. And that equals 414 times 1, which is 414. Now I'm going to divide both sides by 23, because I want x by itself. Fraction bar 23, fraction bar 23, cancel out, bring down x equals. So you should be taking the time to calculate to see if you're doing this right. 414 divide 23 and write your answer down. Now I hope I got the same answer that you did. I got x equals 18. So I'm going to write my answer in the box right here. And then let's make a comparison. It said the blank is traveling faster. Well, if the car is 22 meters per second and the bus is 18 meters per second, well, that's more meters per second. So that means the car is traveling faster. The car is traveling faster by 22 minus 18, which means it is faster by 4 meters per second. Once you've done this page, turn to the next one. And let's do number 4 right here. We are now on page 17 of your notes. Let's highlight important information. And now we don't have the boxes to fill out anymore. We're just going to start with filling out our equations, then it'll be easier. In a toy store, the ratio of dolls to teddy bears is 9 to 3. Okay. 9 dolls to 3 bears. If the store has 240 dolls, how many teddy bears are in the store? Okay, so that's a good question. Let's look and see. How many teddy bears are in the store? Well, we've got to build our proportion first. Just to kind of help, I'm going to write dolls and bears over here to kind of give us a guide to go by. All right? And I know I'm going to have something equals something. Let's start plugging in information we know. So, dolls to teddy bears is 9 to 3. So if there are 240 dolls, how many bears is that? Okay? Multiply your diagonals and divide your other side. So 9 times x, that's 9x, equals 3 times 240, that is 720. So we did the multiplying diagonals, now we divide the sides by what's next to x? 9. Cancels out. Bring down x equals 720 divided 9 is 80. But this is a real world problem, so I always ask that my students write a real world answer. So just tell me how many teddy bears are in the store. There are 80 teddy bears in the store. In the store. Okay? Now let's go over to number 5. Number 5 right here. An airplane on autopilot took 5 hours to travel 3,475 miles. So 5 hours to travel 3,475, kilometers, I said miles. What was the airplane speed in kilometers per hour? When you're saying per hour, it means per one. Okay? So let's go with the ratio hours to kilometers. And I'm going to build my equation over here. Okay? In this first part, we have 5 hours. So I'm going to put a 5 up here. And we have 3,475 kilometers. And we want to know per 1 hour. So I'm going to write a 1 here. Let me bring it up where you can see it. And that means over X. That's our mystery. How many kilometers in 1 hour? Now, some people might say, why didn't I put the kilometers on top and the hours on the bottom since we're doing the ratio? You could have. And you could have flipped this to the top too. So we could have had 3,475 over 5 equals X over 1. But that's the beautiful thing about ratios. As long as you have the corresponding parts matched up, we're good to go. So 5 times X is 5X. And 3,475 times 1 is 3,475. Now we're going to divide both sides by 5 because we want X by itself. And that cancels out and bring down X equals. And so 3,475 divide 5. You can calculate it too, see if you get it correct. That would be, did you get it? 695. Okay, real world question needs a real world answer. So that's where we write the speed is 695 kilometers per hour. And I'm going to do some abbreviations just because. Right there, see? 695 kilometers per hour. Okay, one last question before you start your assignment today. Number 6 says, make sense and persevere. So, highlight important information. At a supermarket, a 6-ounce bottle of salad dressing is $1.56. 6-ounce bottle of salad dressing is $1.56, but a 14-ounce bottle costs $3.36. A 20-ounce bottle costs $5.60. Which bottle has the lowest cost per ounce? So we've got to find all of the what we call unit rates. So I'm going to slide this up here, and we're going to build 3 proportions, or should I say proportional equations. Now let me label these. I'm going to put 6 ounces right here, okay, to work on. I'm going to put 14 ounces right here, and over here I'm going to put 20 ounces. That way we can kind of divide our work up. And inside each of these I will build my proportional equations. So there's different ways we can write this. I'm going to go ahead and show you. Let's do it with a table this time. So if I go ounces to the cost, right? We'll build our table like this. And we'll build these all the way across very quickly so we have them to work on. Ounces per cost, ounces per cost, or it could be cost per ounce. Okay, we'll start with this one. For 6 ounces, it's $1.56. Right? And we want to know per 1 ounce. So we're trying to find this. So all we do, let's multiply our diagonals and divide the other side. Do that with me now. Multiply your diagonals. So I would go 1 times $1.56, and then I would divide 6, because this is what we don't have information for yet. 1 times $1.56 is $1.56. Divide 6, and we get 26 cents per ounce. Okay? Let's go to the next one. So 14 ounces. We'll write our 14 in here. And 14 ounces costs $3.36. And we want to know per 1 ounce. So we really don't know this. So we just multiply our diagonals, divide the other number. 1 times 336, divide 14. This is thinking proportionally. And so your answer here, when you calculate it, should be 24 cents per ounce. Okay? Last one. So we have 20 ounces, and we want to know how much it would cost for 1 ounce. We know this is $5.60, and we want to know per 1 ounce. So this is what we're trying to find. Multiply your diagonals. You can use your calculator. In this case, we have 1. And then divide 560 from 20. So 1 times 560, divide 20. And your final answer should be 28 cents per ounce. So which one is the cheapest, you might say? 26, 24, or 28 cents per ounce? Well, that's cheaper. So that means we would answer this question. 14-ounce bottle is cheapest. Okay? Now, ladies and gentlemen, once you've taken these notes, we should have done page 15, 16, and 17. And if you would, please, go ahead and start your Excel for 2-1.